Today we are going to cover just section 12.6a, and it's called the objective, add and subtract rational expressions. Add and subtract. Rational has the word ratio in it, that's an A. Fractional expressions. Alright, now if this is going to go too fast, you can pause it at any time, or you can look up on the website, the high school website, and go down the left column where it says department websites, and then underneath that will be Mrs. Vobel's wiki, and then you can watch it again at home or something. Okay, to get started here, we're going to do adding and subtracting of fractions. That's what rational expressions are. First step is get common denominators. Common denominators, and that's common denominator CD. Secondly, you're going to add the numerators and keep the common denominators. So once you have common denominators, you get to add the numerators and keep the common denominator. Alright, there's two types, those with the common denominator already and those that you have to get common denominators. But we're going to review with fractions without expressions in them. That means no variables. We're going to practice just with fractions first. So in the first one, since you already have common denominators, you simply add the numerators together but keep the one single denominator. Make sure it's reduced. In the second one, you have to get common denominators. What you look for is the least common denominator. The smallest number that they'll both multiply into will end up being 10. So this first fraction needs to be multiplied by 2 over 2. Second fraction does not have to be multiplied by anything because the denominator is already 10. So the new numerator in the first fraction is 2, and then it's over 10 plus 3 over 10. Add your numerators is 5 over 10, and then reduce all the time 1/2. The third problem, you need to get a common denominator, and the least common denominator that 5 and 4 will multiply into will be 20. So the first fraction has to be multiplied by 4 over 4. The second fraction will be multiplied by 5 over 5. The first fraction's new numerator is 4 over 20 plus 15 over 20. Now that they have the same denominator, you add the numerators, it's 19 over 20. And it cannot be reduced, so that's your final answer. Okay, now we're going to graduate to adding and subtracting rational expressions with common denominators. And the first thing you do is you get common denominators. And the second thing is you're going to add numerators over that common denominator. So add numerators and keep common denominators. And another thing you have to do is always reduce. Okay, so these already have common denominators, so it should not be that difficult, but in your numerator, make sure you add only like terms. So you have an x and an x, together is 2x. You have a 1 and a minus 1, those will cancel. That is all over the common denominator, which is xy, and you must reduce your x's, so it simplifies to 2 over y. Second one, this is a big deal here. You need to make sure that when you have a minus, you distribute that minus to the next quantity. So I'm going to put this as plus, and it distributes that negative to the terms in the next numerator. So now I'm going to add like terms in that numerator since my denominators are the same. So in my numerator, I have a 2a minus an a. That gives me just a 1a. And then I have a plus 4. That is going to be over the a minus 1. Now, nothing cancels. You cannot pluck these a's off of each other. This is a quantity. It's all or nothing. And this is a quantity. It's all or nothing. Either they're exactly alike, and you can cancel them, or if they're not exactly alike, you can't just pull parts of them off. So this is done. Okay, number 3, they have common denominators. Going to change this to plus a negative 3xy. Since the numerators are not exactly like terms, these two are not exactly like, so you just write it as 3x minus 3y, xy, all over 3x squared y. They had the same denominator. Now in the numerators, they have a common factor of 3x. So factor it out. The first term you have to hold it with a 1, minus, take the 3x off of the second term, and you're left with a y. Divided by, you can break up that denominator as 3x times an xy. Because of that x squared, I separated it, and you can see the canceling. So your final answer is a 1 minus y over an xy. Now nothing can be canceled because this is an all or nothing quantity. And that is your final answer. Last one, you add your like terms in the numerator since the denominators are the same, but there are no like terms, so write it as x squared plus x minus 12 all over an x minus 3. If you can factor anything out of that numerator, you need to do that. There is no common factor to all three terms, but that trinomial can be factored down into two binomials. It's an x plus a 4 and an x minus a 3. Those will multiply to give you the negative 12 and add up to a positive 1. Then the denominator is an x minus 3, and that quantity matches the x minus 3 in the numerator, so your final answer is x plus 4. Always reduce. Alright, the next section is getting you ready for the second part of this lecture, and you're getting least common denominators. Okay, to do that, you're going to factor your denominators. After you factor your denominators, you're going to use all factors to their highest power. Use all factors. Once they're factored out, you have to use all factors and to their highest power. So we need practice with that. That's how you find the least common denominator, these two steps. So in step number 1, you have a 5x cubed, and in 15 you have a 3 times a 5, and then there's the x. So the least common denominator, you have to use all your factors, so use your 3, use your 5, use your x, but to the highest power. Now the highest power on your x is 3. The 5 only had the highest power of 1, so use it just to the first power. Only once. And so your final answer here would be a 15x cubed. That would be the least common denominator for those two denominators. Second term, there's no way to multiply this x to make it into an x plus 7. If you multiplied this x by 7, it would be a 7x. If you multiplied it by, I don't know what else you'd be thinking to multiply it by, but there's no way to make this x into an x plus 7. And there's no way to make the x plus 7 become an x. So what you need to do is multiply them by each other. It'd be, the least common denominator would be x times x plus 7. And you're always going to leave these types of least common denominators in factored form. In other words, don't distribute. So let me just model this. If I had a 1/3 plus a 1/4, there's nothing that 3 cannot be multiplied to give you 4, and 4 cannot be multiplied to give you 3. So you have to multiply them by each other. The least common denominator there would be 12. That's kind of how this set of denominators work also. You have to multiply them by each other to get to the least common denominator. Next one, looking at these two denominators, they're already factored. There's no factoring them any further. And the least common denominator will be the product of them. There is no way to multiply the x minus 4 to get you to an x plus 6. and there's no way to multiply the x plus 6 to get you to an x minus 4. So to get to the least common denominator, you'll multiply the two denominators by each other. Leave them in factored form. Do not FOIL this out. Leave it this way. Alright, for the fourth problem, factor your denominators. So this one has a common 2. You take it out. You have 2, then the x minus 2 quantity, and then the other denominator is x minus 2. Least common denominator. You have to list all of your factors, which would be 2 and x minus 2, and you're going to list them to their highest power. Well, this has a power of 1 and this has a power of 1, so the highest power in the least common denominator is just to the first. Do not distribute. Leave your least common denominator in factored form. Number 5. First denominator has a common x. Factor it out. You have an x minus 5 left. Second denominator, we'll work on factoring. You have an x and an x, a plus and a minus. It's going to be a minus on the 5 and a plus on 2. So that's correctly factored. Now the least common denominator lists all your factors, x, x minus 5, and x plus 2, to their highest power. This was to the first, this was to the first, this was to the first, this was to the first. That's why you only list x minus 5 once, because the highest power on them is 1. That's your least common denominator. Do not distribute or FOIL. Number 6. Factor the first quantity, the first denominator. You have an x and an x, a plus and a plus, a 4 and a 1. Second quantity, x, x, plus, plus, 1, 1. Your least common denominator. List all factors, x plus 4, x plus 1, to their highest power. This has a quantity of 1, this has a quantity of 1, and aha, this is actually x plus 1 quantity squared. So in your least common denominator, it must show up as squared, because in one of the denominators, it is listed as a squared. So this is the least common denominator. 1 x plus 4 quantity, and the quantity of x plus 1, it shows up twice, so it's to the second power, so it's squared. Okay, so that is the first part of this section 12.6.